Okay, so I've copied and pasted the dot plots for fiber and protein here into our guided notes, and we're going to go ahead and write down some of the ways that we describe the distribution. In the next question, we're going to come up with a way to formalize how we actually describe a distribution, but let's talk about some things that stand out right now. Looking at fiber, fiber ranges from 0 grams to 14 grams of fiber, whereas protein ranges from 1 to 6. When I'm looking at protein, it seems to be more symmetric looking, unimodal, whereas fiber appears to be skewed to the right. There are larger amounts of fiber than there are of protein. The highest fiber value was 14, the lowest was 6 for protein. Fiber has most of the values around 0 or 1 gram, and then there's a group of 3 as well. Those are all kind of the highest peaks that we have. Whereas protein is about 2 or 3. And one cereal has 6 grams of protein and one cereal has 14 grams of protein, both of which seem to be unusual. So let's go ahead and write those down to formalize them. Notice when I am describing these, I am actually giving context. I'm talking about grams, I'm talking about protein, I'm talking about fibers, and I'm saying cereals. If I just said things like 14 was the most, there was a lot of 2s. To what? What am I talking about here? You need to give context. You'll hear me say throughout the semester, give me context. It means talk about what the problem is about. What is it discussing? Now, the acronym that I like to use for describing a distribution is SUCS, S-U-C-S. Some books will use SOCS, S-O-C-S, where the O stands for outliers and the U stands for unusual features. I think that sometimes it's important to talk about unusual features in addition to outliers and gaps. So I like to use SUCS when I'm describing a distribution. The first S stands for shape. We're talking about the shape of a distribution. Is it symmetric? Is it unimodal? We'll talk about how you describe shape, how you describe the unusual features in the next few questions. The second letter, O or U, O is for outliers, if that's the acronym you choose to remember. And U is unusual features. The C stands for center. And the second S stands for spread. That's the variability. So you're talking about what the picture looks like, where the typical value is, what the overall spread of the distribution is, and are there any outliers? Is there any unusual features like gaps? Now, when I look at the distributions below, I want to pretend that I'm drawing a blanket over the distribution so I can kind of get an idea of what the picture looks like. So imagine kind of drawing a line on top of these pictures to help you describe what the distribution looks like. In each of these pictures that we've drawn, these 5 pictures, we could describe their distribution using the shape, the center, the spread, and any unusual features. So if I asked you to describe the distribution, I would be looking for the things that I've listed here. How do I describe the shape of a distribution? When I'm talking about shape, I want to know what the overall picture is. Is it symmetric? Is it uniform? Is it left or right skewed? And how many modes are there? How many humps are there? I like to say, like, is it 1 hump? Is it 2? Are there lots? So we're going to first talk about the overall picture, symmetric, uniform, or skewed, and then we're going to talk about modes. A symmetric distribution is one in which if you folded the distribution in half, the left side and the right side would match up. Doesn't necessarily have to be a normal distribution or a bell curve. It just means that the left and the right are symmetrical. A uniform distribution is symmetric, but it's a specific type of symmetric distribution. A uniform distribution is when your whole distribution is flat across the top for the most part, which you would see in the last graph, the last digit of phone numbers, where it's not identical across, but it's almost close. It's uniform, where basically each value is likely to be the same probability. It's likely to occur the same amount. Skewed right is the same thing as skewed positive. Skewed left is the same thing as skewed negative. I prefer right and left. And a lot of people will confuse skewed by saying the wrong side. Skewed to the right means most of the data is on the left. Skewed to the left means most of the data is to the right. It's because your tail or your skewness is pulled to those unusual values, not the actual normal values you would expect. A distribution that is skewed to the right might look something like this. And a distribution that's skewed to the left might look something like that. So your tail, the lower part, is pulled out towards wherever your skewness is. Talking about modes, unimodal means there's one clear group of high data. Like there's the most counts occur for one group or one kind of clumped together. Bimodal means there's two groups that have high counts that are separated from each other. It's not just one, like two that are close together. It's got to be separate values where there's a valley in between them. And then multimodal is anything more than bi. If I go back to the pictures that I had before, I would say sugars might be considered bimodal because you've got the 3 grams for children here that has a higher peak, and then also the 12. Or you could say it's skewed to the left. I might consider that bimodal. But the child for calories, that is symmetric-ish. I know that there's one clear unimodal peak. I would say calories is symmetric with one unimodal peak. I would say sugars for adults is skewed to the right with one unimodal peak because there's not another jump off. And then I would say that counts is uniform. And it's not, when you talk about a uniform distribution, you're not going to have bimodal, multimodal, because it's all, the whole thing is the same. Now, the second letter, we've just talked about the shape. The second letter is either O or U, outliers or unusual features. I think some people prefer SOX just because it's not as crass as SOX. But I would say the unusual features you want to talk about is you want to talk about outliers and you want to talk about gaps. Having a gap does not guarantee that you have an outlier. An outlier is 1.5 times the interquartile range. We'll talk about that later. But just because a point is a little bit away from data does not mean it's guaranteed to be an outlier. But you might want to say there is a gap present if it's noticeable, if it's something that you think is important. Describing the center of a distribution, we are going to talk about a typical value using either the mean or the median. That is in the next module. We'll talk about both the mean and the median, but you use one in one specific situation and use another in a different situation. In a symmetric distribution, you use the mean. In a skewed distribution, you use the median. And for the spread, we haven't really formalized anything yet. We will in module 10, actually 9 and 10. We'll talk about one form of variation in module 9, and we'll talk about another in module 10. But the spread of a distribution is how variable. Variability is how spread out your data is. Is it really close together? Is it really far apart? So we use spread as a term to describe variability. And we can use the range. We can use the interquartile range. We can use the standard deviation. You can use the ADM. We'll talk about each of these. There are two that we prefer. In a skewed distribution, we prefer the interquartile range, which we'll talk about in module 9. And in a symmetric distribution, we prefer the standard deviation, which we'll talk about in module 10. The median and the interquartile range are married together, and the standard deviation and the mean are married together. They actually are, those are the two that you would use depending on the distribution. And you'll see when you make a box plot how the median and the quartiles are listed, and you'll see when we calculate the standard deviation, it relies on the mean. I'm going to pause the video now, head on over to the next video to continue the section.